All right, welcome back. We are on episode 27. We will be covering Python iterators. So an iterator is an object that contains a countable number of values. An iterator is an object that can be iterated upon, meaning that you can traverse through all of those values. So in Python, the object has the Iterator Protocol, and that just consists of two methods, which is the double under iter method and dunder next. So we've seen those with init. Just know that it has those. The difference between an iterator and an iterable is like lists, tuples, dictionaries, and sets are all iterable objects. So they are iterable containers which you can get an iterator from. All of these objects also have an iter method, which is used to get an iterator, and that method just looks like this. So, did I misspell it? So that's what the iter method looks like. So to demonstrate this, we'll just comment out this iter method here, and we'll just build a list. It'll just be a sample list. We'll use some really creative values in here, and then we have to assign this to another variable, so we'll just call it my iter, and we'll set that equal to iter of my list, or sample list, sorry. And then we'll be able to print this. So if we just print sample list, obviously we'll get the entire list. But what we want to do is show that next function. So we'll just print my iter and delete sample list from here. Fix our brackets. So if we do this, it will actually only print the first iterator. So the list is an iterable object, something we can iterate over, and the iterator is the first thing we get back. So my iter right here is just going to return 1, and I'll just save that and show that really quick. So we get 1, but by using this next method, if we copy and paste this print, even though we're not telling it to do anything, we're not building a for loop and telling it to count up, anything like that. Now if we save, come down here and run it, you see that it still iterates over that list and gives us 1, 2, and 3. And just remember, even strings are iterable objects, so those can even return an iterable. So even though this variable is poorly named, we'll just change it to a string. And then if we just leave these 3, we're only going to get the first 3 characters back. So we'll go up to 6 here, save, print, and you see we get each character in the string as it iterates over that string. Now just remember that this is probably not the way that you would use this. Just know that it exists and that what it means. Obviously, if we wanted to loop over something like this, we would just do like for char in sample list, even though it's a string, so not a list. We could just print that char, and we're getting the same result, obviously with much less code, and it's fluid. If we add stuff, even if it's misspelled, save, run, we get the entire printout string example instead of having to copy and paste that next my iter over and over again. So what we're doing with a for loop is we're actually creating an iterator object, and we're executing that next method for each loop. We're just not typing it out explicitly, it's doing it behind the scenes for us. Now you can create your own iterator object, and for that, we'll just comment this out. So we comment that out, and then we'll just build an object here. We'll do class, and we'll just call it num iterator here. And then to make it an iterator class, you have to implement methods iter and next, those dunder methods that I just spoke about, but I haven't shown those yet. So right here we'll do this, and remember how we normally do like the init for an object. We're using this iter. We're going to pass self into this iter. And then we can just do self dot whatever variable we want, self dot a equals 1, and then we can just return self. Now down here we will do next. So we'll define our next method inside of this object, this iterator object or class that we're building. And then we want this one to handle the value for the next variable. So we'll just do x equals self.a. So we'll set that to that. And then we'll do self.a. And we want to increment that plus or equals 1. And then we're going to return x. And so that's any time that somebody calls that next, like you saw us doing when we were printing and we were doing the next my iter of the list. How we were getting it to return is this. So it was just doing, it was incrementing it. So, and returning the value of that. Which, if this is confusing, that's totally fine. So we'll just kind of demonstrate. And we'll just say like num class equals, and we'll do num iterator here. And then we'll set that my iter again, and we'll iter over num class. All right. And then here we can just print like we did before, next, and pass in my iter. So save. Hopefully this all works, and we're getting 1. So that's what we wanted. Let's see if it's incrementing appropriately. And you see now we don't even have to pass in a list because we built a class that just starts at 1 and increments up. So our class object automatically has those functions built in. We're calling this next function on self, and we're incrementing the value. So if any of that's confusing, that's okay. Just you can mess around with it, but just know that we built our own iterator class here, and that's what we're doing. One important thing to note is that if we were to do this in a for loop here, it would just continue indefinitely. So if we were doing something like this, for x in my iter, and we were just printing x, kind of like how we showed before with the for loop, if we do this, it will just keep running this indefinitely. So we want to put something in here to stop that in our class. So we'll put a conditional statement, and we'll say if self.a is less than or equal to 10, then we'll allow this stuff. And we have to now indent because we're using Python. And then we can do an else statement, and we can use this stop iteration, which is a statement. So this is what it looks like. You want a space between raise and stop iteration in there. And then now this should not run forever. We can save, for loop it, and you see it stops when we hit 10 after returning 10. You'll notice when we get to data structures and algorithms and stuff that you build your own class to solve a lot of problems, and you might be wondering why this matters, but hopefully you did the object-oriented programming D&D application with me, which we started, and if you did, I think this will make a little bit more sense, hopefully. If not, then we will dive into it when we get to data structures and algorithms. Thanks for tuning in, and that concludes Iterators. If you want more practice, again, you can go to w3schools.com, and they have exercises for you to practice this as much as you want.